Okay, here we are, moving on, 4.3a. So this one is on trigonometric functions on the unit circle. So one of the things we're going to try to do is the objective, determine reference angles, and then find values of the trigonometric functions for general angles. Okay, so we'll find out what those are, and then we're going to kind of use SOHCAHTOA again and use for your sine, cosine, tangent, secant, cosecant, cotangent. Yeah, go from there. So let's first start out with the reference angle. So this is an angle that's formed by the x-axis and the terminal side of theta. Okay, so one thing we have to remember on this one is that they are always positive. Okay, so that's one thing, just make sure we know that. So even if you get a negative answer here, just turn it to positive. The reference angle is always going to be positive. Okay, we symbolize this thing by theta prime is what we call it. Okay, so with theta with a little dash, so it's theta prime, that's how we say it. And in a diagram, there's not going to be any arrowheads. So there'll be an arrowheads for the initial angle, and then when you find a reference angle, you won't put an arrowhead on it. Okay, so a lot of this will be easier to understand if we look at some examples. Okay, so for any non-quadrantal angle, well, don't worry about that term, right? Because we're actually going to talk about this one later, non-quadrantal. It's actually an angle whose side lies on one of the axes. We'll talk about that later on here. Okay, but for this, if it's not on the axis, it's just a regular angle here. We've got these different things that we can reference here. Okay, so for instance, quadrant 1. So you can see here that this would be, let's say, just for example, if it's in quadrant 1, it's pretty simple. Theta prime equals theta. So if we knew already here that we had a reference angle, let's say it was, our reference angle was 50. So let's say that this was 50 degrees here. So in this case, our reference angle would also be 50 degrees. That's an angle, okay? Or we would say theta prime equals 50 degrees. Those would be the same, right? If we showed this on there, we would do this and not have an arrowhead. We'll show those a little bit more later on in some different examples. Okay, so in this case here, quadrant 2, so you got different things. You can use these different formulas for each of them, right? So just to help you find it. Sometimes it's easier. Sometimes you can just look at it and know what it is and you can find it. But if quadrant 1 is pretty simple. Quadrant 2, you're just going to take 180 and minus whatever that angle is. Okay. Quadrant 3, you're going to kind of do the opposite there. You take theta and subtract 180 from it. Or in terms of radians, you're going to go pi, right? Because pi is 180 minus theta, or theta minus pi. And if it's in quadrant 4, right, we're talking about 360 degrees, so we would find it by subtracting that angle, or we could use 2 pi if we're talking radians, because 2 pi is equivalent to 360. Okay, so let's just look at some examples of those as well. So let's say that this angle here was 150, just to kind of just give us an example. Let's say that theta was equal to 150 here. Okay, so in that case, we're going to take 180 minus 150, and you would get theta prime, like that. Oh, cool. So theta prime would equal 30 degrees, okay? And that would be right here. Notice that there's no arrowhead with that, okay? All right, next. If we did one from here, let's say we had this angle here is 210 degrees. Let's say that's going all the way around. So our reference angle, again, goes from the x-axis here. Again, no arrowhead, as you can see. So for this one, theta prime is actually going to be 210 minus 180. So kind of get the idea that whatever quadrant it is, you use that sort of thing, that kind of formula, and you'll get your answer no problem. And there you go. Okay. And the last one here, if you've got an angle, let's say this goes all the way around and was 300 degrees, like this, okay? Then our reference angle comes from the x-axis down here, and we would go for theta prime, we'd say 360 minus 300, which would equal 60 degrees. Okay, now you might be saying, okay, well, but this angle here is a negative. We're going negative, should be a negative 60 degrees. Okay, but it's a reference angle, and so you're going from that x, so the reference angle is always positive. Remember that from up here? It's always positive. Okay, so we can get the idea there. Okay, just remember a couple things, that if theta is actually over 360 degrees, then you'll need to find a coterminal angle, okay, which we did in the last sections. You just have to find an angle based on those rotations to find something coterminal to find it. And then leave answers in the same form as the original problem. So if we did, like, if we were talking degrees, leave it in degrees. If we're talking radians, then you leave it in radians. Now, with that said, I should point out that if you find it easier, I'll just put a star here and talk about it. But if you find it easier, you can switch it to degrees. If it's easier, and you might want to do that on some of them, you might not have to, because they're easy. You can just see what it would be with radians. But some of them are a little bit tricky. But we want to put afterwards, after we get the degree, put back in radians. So when you're actually solving the problem, you can graph it, and you can do the work in degrees and then put it back in the radians just by multiplying by pi over 180. All right, so let's try some of these. So we've got 330 degrees. So our first angle as we graph is going to be here, all the way around to about here, right? 330, give or take. Okay, so this is 330 degrees. And I'm actually going to put an arrowhead here because that's, the initial angle. And so my reference angle will be right here, okay? Notice that there's no arrowhead there, okay? And that's how we can decipher what's the angle and what's the reference angle, okay? And so we can kind of just look at this as 360 minus 330, so I know that this is going to be 30 degrees in here. So theta prime is equal to 30 degrees. Okay? All right, so let's keep going here. Like I said, you could do this. So especially when it helps to graph, because maybe we don't know how to graph this right off the bat. So I could take this and I could say 180 over pi and make that negative 150. So then that might be easier for me to graph. If I take this and say, okay, negative 150, I know that's going to be over here. So negative 150, if I do that, which is negative 5 over 6. So when I put it out back on there, negative 5 pi over 6. And now you might be able to tell that this here, this reference angle here, again, comes from the x-axis down here, no arrowhead. And that's going to be pi over 6, because 6 over 6, 6 pi over 6 would just be pi, which would be 180 degrees. So sometimes you can see that fairly simple. Otherwise, you're going to have to do the math, and it might help to do the math in degrees first. And then go back if you wanted to. For example, if we did the math on this one, then you would get a 30 degree, right? 180 minus 150 would be 30 degrees. And then I could convert that into pi over 6 if I needed to. All right, here's another one. So I could do that again. I could say 180 over pi equals 120 degrees. So my 120 degrees angles, this would be 90, and then 120 would be right up here. So that would be 120, put the arrowhead there, 120 for theta. And then that tells me that I could do this as well. I could say, well, what does this have to be from the x-axis up? So doing that, well, then I know that has to be, what, 60 degrees? But here's where we talked about putting it back into radians as well. So I could go 60. Now I'm going to multiply by pi over 180 just to kind of do the opposite of this, right? So then I get 60 over 180 pi, which equals 1/3 pi, okay, or pi over 3. Okay, so I think we get the idea, and so I'm going to move on. I'm going to let you guys kind of try those ones out on your own, just so we can move through the video a little bit faster. All right, now we want to get into some other stuff here. We're already at 11 minutes. All right, so now let's talk about the trig functions. So if we have an angle in standard position, if we have theta in standard position, then we can let any point be x, y on the point. We can find some different distances with the Pythagorean theorem. So this is a lot of text here, but just kind of get the idea that we're going to use Pythagorean theorem, find the distance, and then we can get the trig functions by using these things. So if I have a point x, y over here, right? So I've got my x value, my y value. I can draw those and make a right triangle. And with my angle being my r value. So that's where Pythagorean theorem comes in, because I can find these values given what I have. And then I can find all the 6 trig functions by using this. Sine of theta is going to be y over r. Cosine of theta is going to be x over r, and these are all in your notes. Tangent theta, y over x, but remember we can't have 0. Cosecant is the reciprocal of that. The secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So again, we can keep remembering, we can do it with these functions, y over r, x over r, y over x, with these variables, but we can also use SOHCAHTOA. It's the same thing, right? If you're going to take this angle here and check out this angle, well, sine would still be opposite y over hypotenuse r, as you can see here. So it's still using SOHCAHTOA. Sometimes it helps to use the variables. Sometimes you want to use SOHCAHTOA. Okay, so to do this, what we want to do to evaluate trig functions, if they give you a point, is we're going to plot the point. That's the first thing. Plot the point, graph it, okay, and draw a reference angle from the x-axis. Okay, so we'll just kind of do that. We'll show you how to do that. Then you're going to draw a right triangle with your x-axis and the hypotenuse. So your hypotenuse is going to be r. So you've got your reference angle. You'll have your x, y, and r, basically. So use x, y, and r values to evaluate those trig functions, like we talked about up here, okay? And then just remember that r is always going to be positive. That's your reference angle. It's always going to be positive. So x and y can be negative. So they could be positive or negative. Use the signs, right? So if it's going to be it could be positive or negative, just depending on what quadrant it's in. Okay, so let's kind of talk about those. Find the exact values of these. We want to label it, leave it in simplest form. And again, like I said, remember, you can always do SOHCAHTOA. That's always important to do here. Okay, so let's look at an example here. So point is at 8 and negative 15. So if I draw this, then what I want to do is if I take 8 and negative 15, so that's going to take me over here is 8, and let's say negative 15 is down here. It doesn't have to be exact. We just know that this value here is 8. This value here is 8, and that this value here is negative 15. So I can draw my line here, right? Here's my initial side, and my terminal side, my reference angle is going to go here. That's going to be my R value. I don't know what that is at this point right now. Okay, but I know that this x is 8 and y is negative 15. So I can find my r value by using Pythagorean theorem. So using that 8 squared plus a negative 15 squared equals r squared. And just doing that math here really quick, I end up getting 289. Square root of 289 equals r squared. So r is equals to 17. Okay, now, so here's my values, right? I've got x equals 8. I've got y equals negative 15. And my r value always has to be positive. And it is in this case, it's 17. So now when I find these values, I'm just going to kind of write them all down here. And again, I just point out I can use SOHCAHTOA, or I can use the values I have, right? I can use the x, the y, and the r. Okay, so sine, we know if we're talking about this angle, so sine would be opposite over hypotenuse. So opposite negative 15 over 17. Okay, and again, that's the same thing as saying y over r, which we talked about up here. So you can use these values right here as well, whatever helps you. Okay. All right, so cosine is adjacent over hypotenuse, so that's going to be 8 over 17. And then tangent is opposite over adjacent. So with tangent, we've got negative 15 over 8. All right, now we know that the other ones are just reciprocals of each. Cosecant, the reciprocal of sine, so negative 17 over 15. Secant would be 17 over 8, because it's the reciprocal of cosine. Cotangent would be negative 8 over 15, because it's the reciprocal of tangent. All right, so let's try this one. Now, the other thing is, if you can reduce them early, because it'll help you, because we got to reduce everything and make sure it's in the simplest form. So let's take a look at this one. We've got, the point is at 4, 4. Okay, so in that case, I've got 4 on x and 4 on y would give me my point right here of 4, 4. Okay, so I draw this line here and I draw my right triangle with the reference angle. And now I'm good to go. I know this distance is 4 and this distance is 4. R I can figure out. So I can do that with 4 squared plus 4 squared equals r squared. So you're looking at 16 plus 16. So 32 equals r squared. So r equals the square root of 32. But remember, I can break that down into the square root of 16 times the square root of 2. And the square root of 16 is 4. So r is actually equal to 4 times the square root of 2. So we want to make sure we know that stuff. So up here, I've got 4 times the square root of 2. Now, this is reducible, though, because I've got a bunch of 4s. So this 4 and this 4 can cancel and be 1 and 1. I can also cancel that out, so my hypotenuse is the square root of 2. It's really a 45, 45, 90 right triangle, if we know that. So what helps us is it's already in reduced form. So I know my x equals 1, my y equals 1, and my r equals the square root of 2. Okay, so I can use all those values to find all the trig functions. Now, the one thing I would point out is by doing that reduced, now I won't have to do it, for the most part, I won't have to do it later on. Now, there are some occasions where you can't reduce them right away and you have to reduce them while you're in the ratios, the trig ratios. But for the most part, if you reduce them here, it saves you work when you get them into the trig ratios. For the most part. And just remember, again, you can't have a radical in the denominator, so that might be something you have to do if that happens. Okay, so in this case, sine opposite over hypotenuse, or y over r, would be 1 over the square root of 2. But remember, I can't have that I can't have square root of 2 in the denominator, so square root of 2 over 2. cosine is going to be the same thing. Tangent's going to be 1. And then my reciprocal is going to be square root of 2 here, square root of 2 here, and 1 here for all my values. Okay, how are we doing on time? Still got some things to cover. All right, so let's go to the next page. Now, we talked about quadrantal angles. Fun word to say. So these angles are where you lie on an axis. So we actually have a point on an axis. Okay, you're going to do the same thing you just did, and it actually makes it a little bit easier because in this case, we know that our R value is always positive, so it's going to be absolute value of either X or Y, whatever that is. The other one's going to be 0, depending on what axis it's on. So what axis is it on will determine which one's 0. Okay? And again, once you see examples, it's not as bad. But this case, you know that you're going to have a value of 1 for X or Y. You're going to have R is going to be the absolute value of that, so always positive. And then the other value is going to be 0. Okay? So let's just kind of take a look here at these. So in this case, let's say we have an example where this is 4. Let's say it was 4, 0. Okay, well, because you can see this angle lies on the axis. All right, so in that case, we could say, well, X we know is 4 because it's 4, 0. Y would be 0 because we're not going up or down at all. And then your R value is going to be the absolute value of X in this case, which is 4. So you could find those out. All right. Same thing here. Let's say we have a different one where this was 0, 3. Okay. Well, in this case, X, we didn't move. Here's your angle. It lies on the axis. X didn't move at all left or right because our point is here. So X is 0. And Y would be 3 because we're up 3 points here. And then your R value would be 3 as well. Right? Well, what about when we deal with negatives? So in this case, let's just use the example -2, 0. Okay, so in this case, I know X, because it's X is -2 on the point, it's going to be there. I know my Y value because of the point is 0. Same thing we did. We just know that R now is going to be the absolute value of this X, so R will be 2, and we could find the ratios that way. Okay, and then here, let's say we have a -Y, so let's say it was 0, -5. Again, I know my X is 0. My Y is -5 because that's what the point is. And my R is going to be the absolute value of -5, which makes it +5, so I can figure that stuff out. Now, notice what you notice. Hopefully, you notice this, that when you reduce those on the triangle, you've got a 4, 4, you got 3, 3, -2, -2, -5, -5, or -5, +5, -2, +2, and 0. So when this kind of works out nicely, because when you reduce them, another reason why reducing them early is important, because when reduced, the values will always be positive, -1, 0, or undefined. Right? Because if you have a 0 in the denominator, it would be undefined. But you can reduce these. You can see it's always going to be +1, -1, or 0. All right, so let's work on some of these. Find these values of these 6 trig functions, and if the terminal side contains this point. All right, so again, now I don't even really need to graph this because I know that X equals -2. I know Y equals 0, and R is going to be +2 because it can't. It can't be negative, and it has to be the absolute value of one of those. If we reduce these, right, then X is equal to -1, Y equals 0, and R equals +1. So now I'm able to use these for my trig values. Okay, so Y over R, or opposite over hypotenuse, would be 0 over 2, or 0 over 1. I'm going to use these values here. 0 over 1, so 0. Cosecant is going to be x over r. So x over r, which is negative 1 over 2. Or sorry, yeah, x over r, negative 1 over 1, which is negative 1. And then tangent is going to be y over x, so 0 over negative 1, which equals 0. Okay? And then if I go my other ones, these are just, of course, remember the reciprocals of the other. And I could use the x over y and r over y over x if I wanted to do that too, but I can just take the reciprocal. So I know that with 1 over 0, and the reciprocal is going to make that undefined right here, right? Secant would be still be negative 1, and cotangent would be undefined because I'd have a 0 in the denominator as well. Okay, let's try another one. So in this case, with y now, so I know x is 0, y is negative 5, and r is got to be the absolute value of that of 5. So reducing, x is 0, y equals negative 1, and r equals positive 1. Now I can find those values again. And say sine is negative 1, cosine is going to be 0, and tangent is going to be undefined. Cosecant, secant, and cotangent, the reciprocals of those. And again, I'm just using those ratios and SOHCAHTOA to find these out. And using these values here, because they're reduced, it makes it a lot easier. So cosecant, also going to be negative 1. Secant is going to be undefined. And cotangent is going to be 0. All right, last thing here. So suppose we have an angle here where it's in standard position and it's in quadrant 3. So they give us the quadrant 3, and they give us that they have this cosecant of theta is negative 5 over 3. So find the remaining 5 trig functions. Okay, so in this case, we might need to draw a graph, and we know that it's in quadrant 3. So that's over here, right? It's down in this area. So knowing that, I've got negative 5 over 3. Well, what is cosecant? Cosecant is going to be, if we look back here, cosecant is r over y, okay? Okay, so this would be my r, this would be my y value. But remember, r can't be negative. So that means, even though we have a fraction here that's negative, that means y must be a negative 3. Remember, we can write the negative either way we want. Okay, so that puts us here at, especially because we know we're in quadrant 3 also. Okay, so that's going to give us an r value here of 5, since we're in quadrant 3, right? So this would be my negative 3 for y. This is my r value, which is going to be 5. And then I don't know my x value. Okay, but remember, I can figure that out by using Pythagorean theorem. Negative 3 squared plus, negative 3 squared plus x squared, just to make sure we're doing it the correct way. 5 is your hypotenuse, so it goes there. So I'm going to have 9 plus x squared equals 25. Works out nicely that x squared equals 16, so x equals 4. So I know that this is a 4. Now I can go ahead and just remember also, though, because it's in quadrant 3, that x has to be negative 4. Okay, so now I have my values. I've got x equals negative 4. I've got y equals negative 3, and I've got r equals 5, and I really can't reduce them anymore, so I'm just going to go ahead and plug in those functions here. And even though we have cosecant already, I just wanted to, put them all 6 down and just get in the habit of doing that as well. Okay. And so now we use these ratios here, these numbers and the ratios we have. So we have -3/5 here, which means that this is going to be -5/3. We know that. Cosecant -4/5. So that means this is going to be -5/4. And then tangent 3/4, which means that cotangent is going to be 4/3. Woo! Okay, a lot to cover there. Bring your questions in. Just a shade over a half hour. Wow, we covered a lot of ground though. So bring your questions in. Not that tough of stuff, but just a lot of it. See you